Welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. I'm Mr. Jensen. We're looking at our second section of the course, Functions and Models. We're going to talk about mathematical modeling today. Okay, what a mathematical model is, it's an equation that we can use to represent data in a real-life situation, in a scenario. So if I look at my first example here, for your 10th birthday, your grandparents gave you $200 to begin saving for college. Because you don't know anything about saving, you keep the money in a box in your bedroom. Each year on your birthday, your grandparents give you another $100. Remember, they gave you $200 to begin with. Each birthday, another $100. You put that in the box. Just after your 18th birthday, you're preparing for college. How much money will you have in the box? Now, first of all, I'm going to write my model. F of x, y equals f of x. The amount of money I have in the account is the function of x, the number of years after my birthday. So it's never a bad idea to say x is years after your 10th birthday. So you give a representation as to what x is, and you make sure that we're aware of what x represents. F of x, it was originally $200. On your 10th birthday, your grandparents gave you $200. They gave you another $100 each year, where x represents the number of years. So if I want to know how much money I have in my account after my 13th birthday, x would be 3. After my 15th birthday, x would be 5. Notice the question is, just after your 18th birthday, how much money do you have in the account? F of 8. We're going to use 8, not 18, because x, remember, is the number of years after your 10th birthday. So that would be 8. So 200 plus 100 times 8 would be 200, plus 800 is 1,000. You would have $1,000 in your account after your 18th birthday. This function is linear because the amount of money that's being added to your account each year is the same amount. Your account is growing at a consistent amount. Okay, we talk about linear functions having a constant rate of change. That is true. It's an additive rate. We're adding the same amount each birthday. Example 2. For your 10th birthday, your grandparents gave you $1,000. So instead of giving you the $1,000 over the years, they just give you $1,000 on your 10th birthday. They tell you that's all that they're going to be able to give you, so you invest the money in an account paying 8% interest compounded monthly. Just after your 18th birthday, you're preparing for college. How much money will you have in the account? Now, our second unit of this course is going to have a lot more to do with investments and growth and equations, with all of those things in the functions and modeling. But we're going to say that f of x, the amount of money you have in my account, again, x is the years after your 10th birthday. But I'm going to take the $1,000 and I'm going to invest it in an account paying 8%. So I'm going to multiply that times 1.08 to the x. Okay? So that will be the amount of money that I have in my account after x years. After my 12th birthday, 2 years later, x would be 2. 15th birthday, x would be 5. After my 18th birthday, x is 8. So I'd have 1,000 times 1.08 to the 8th. And I could calculate that. Okay? Now to calculate that, I'm going to use, bear with me here, I'm going to use my graphing calculator. So let's clear that. We're going to have 1,000 times 1.08 to the 8th. And so we would have 1850.93. 1850.93 is how much money we would have in the account. Okay. Third example, suppose I have 120 feet of fence and I need to enclose a rectangular garden. Write a model for the area of the garden. Now the garden is going to be rectangular. Here's the length and here's the width. We know that area is length times width. But we say we want to write the area as a function of its width. So what we need to do is we need to express length in terms of the width. So we have 120 feet. So the length on this side, the length on this side, the width here, and the width here, that's 2 lengths and 2 widths, is my 120 feet of fence. If I divide everything by 2, I know that 1 length plus 1 width would be 60. And so my length is 60 minus the width, because we're going to subtract W from both sides. Now I want to take that 60 minus W and substitute that in place of the L. So my area is equal to the length, which is 60 minus W, times the width, which is W. Now notice this is a function of just W, so now we could say my area as a function of the width is 60 minus W times W. Okay, so this is the model that represents the area of a garden as a function of its width if I have 120 feet of fence. Okay. Some models that we can look at, right? The cost of renting tuxes for Choral Society's formal is $20 down plus $88 per tux. Express the cost as a function of X, the number of tuxedos rented. So I'm going to write that my cost as a function of X, the number of tuxedos rented. First of all, I have to pay $20 plus I have to pay $88 per tux. There are a lot of people who will say that they want to write that function with the 88x first plus the 20 to put it in that y equals mx plus b format. Personally, I don't care. In fact, I prefer writing it cost me $20 plus $88 per tux. So my cost of renting 2 tuxes is 20 plus 88 times 2. Okay, so if I go back to my calculator, 20 plus 88 times 2 would be 196. It will cost me $196 to rent 2 tuxes. However, what's the cost of the second tux? The cost of the second tux is $88. The cost of the first tux is $88. The second tux costs $88. The third tux costs $88. What about the 10th tux? The 10th tux is also $88. The overall cost, though, includes the previous tux and the $20. Okay? So we have variable cost, we have marginal cost, okay? And we have fixed cost. So when we look at the variable cost, the marginal cost, and the fixed cost, I'm going to do these not in this particular order. I'm going to talk at number E, the fixed cost first. When I rent tuxes, the fixed cost is $20. That's fixed. If I rent 1 tux, I have to pay that initial cost. If I rent 2 tuxes, no matter how many tuxes I rent, I'm going to have to pay that $20. That's a fixed cost. My marginal cost is the cost per tux. My cost per tux is $88. So my marginal cost is $88. I'm going to omit the dollar sign for right now. My marginal cost is $88. The variable cost is simply the 88x. Okay? 88 times 2 is the variable cost for 2 tuxes. 88 times 10 is the variable cost for 10 tuxes because it costs F, marginal cost, $88 per tux. Okay? So if I look at the function itself, 20 is the fixed cost, 88x is the variable cost, but 88 is the marginal cost. So that's a little bit of vocabulary there. A linear model. Okay, remember we said linear model, we have a constant amount of change. The rate of change is the same. So if I look at this model here, this table shows some annual revenues in billions of dollars earned by Amazon beginning in 2004, running through 2014. Notice that the change in the first 2 years is $4 billion. Yes, these are $1 billion. $4 billion. The change in the next 2 years is 8. The the change in the next 2 years is 15, and the next 2 years is 27, and the next 2 years it's $17 billion. The amount of change is not consistent. So a linear model would not best represent this data. We'll talk more about that in future sections, so stay tuned for that information. First, I want to talk about supply and demand. Okay, you've heard of supply and demand, I would imagine, I would hope. You've heard of the concept of supply and demand. As the supply of a commodity increases, the cost tends to decrease. Or if the demand increases, the supply would decrease, right? So we want to look at supply versus demand functions. The demand for a commodity usually goes down as the price goes up. The demand increases when the price goes down. Okay, a demand function will give the demand Q, where Q is quantity and P is price. Supply function, the supply Q, the quantity I have in supply is a function of price. Equilibrium price is where the supply and demand functions are equal to each other. Okay, so the demand function for your exclusive t-shirts. So look at this example. You have a t-shirt company. You have these wonderful t-shirts that you make. Your demand function is Q equals negative 20p plus $800 shirts, and Q, the supply, is Q equals 10p minus 100 shirts, where P is the price. What's the demand and supply function if the price of the shirts is $15? So demand. Q would equal negative 20 times 15 plus 800. And our calculator, negative 20 times 15 plus 800 would be 500. Okay, so if the price is set at $15, the demand for t-shirts would be 500 per day. My supply function, we said, is Q equals 10p minus 100. So if my price is set at 15, 10 times 15 is 150, minus 100 would be 50. My supply would be 50. So you notice I've got a demand for 500 t-shirts, but only a supply of 50. It's not a good scenario to be in. I could be selling more. If I raise the price, I'm going to decrease my demand, but I'll increase my supply. So my question is then, what would be my equilibrium price? What price do I need to set my t-shirts at so that my demand function of negative 20p plus 800 would equal my supply function of 10p minus 100? Now, to do that, I'm going to add 100 to both sides. I'm also going to add 20p to both sides. Notice that 900 will equal 30p, where 30p will equal 900. If I divide both sides by the 30, p is equal to 30. If I set a price of $30, my demand and my supply will be equal to each other. Okay, and you could test that out. I want to kind of allude to or finish up this video by looking at some algebra dealing with functions. We talk about a function that is the sum of two functions, f plus g of x. I add the two functions together. To find the difference of two functions, I subtract them. To find the product of two functions, I would multiply them, and the quotient of two functions, we divide them. So I'm going to use the same set of functions here. F of x is x squared plus 3x minus 5. G of x is 3x minus 2. If I want to find the function f plus g of x, which is the sum of two functions, I'm simply going to add f of x plus g of x. X squared plus 3x minus 5 plus 3x minus 2. And to add those two functions, all I need to do is simply combine like terms. X squared, then I have a 3x and another 3x is 6x, minus 5 minus 2 is a negative 7. F plus g of x equals x squared minus 6x. Now you're writing a function here. This is one of the things, I'm glad you're watching this video. You'll catch this when you take my test. Since you're finding a function, you must write a function which is in an equation format. To find f minus g of x, it's going to be the f of x squared plus 3x minus 5, minus, let me fix that parenthesis real quick, minus g of x, which is 3x minus 2. It is important to use the parentheses here. So again, we have x squared. 3x minus 3x is 0. Negative 5 minus negative 2 is a negative 3. So f minus g of x is x squared minus 3. To find the product of the two functions, f of x times g of x. Now I'm going to multiply these. I'm going to use my colors. First, I'm going to distribute the x squared to each of those two terms. So x squared times 3x is 3x cubed, and x squared times negative 2 is negative 2x squared. Then, I'm going to distribute the 3x. To the 3x is 9x squared. 3x times negative 2 is negative 6x. Lastly, I'm going to take the negative 5 times 3x is negative 15x, and negative 5 times negative 2 is plus 10. Then I'm going to look for my like terms to combine. Notice I can combine these like terms and these like terms. So 3x squared plus, that's 3x cubed plus 7x squared minus 21x plus 10. F times g of x is 3x to the third plus 7x squared minus 21x plus 10. Now, the division of the two functions, the quotient of the two functions, in one aspect is easier than the previous three, in the other it's got a little twist. So I'm going to divide f of x by g of x. So f of x is x squared plus 3x minus 5. Divide that by 3x minus 2. And I want to say that f divided by g of x is x squared plus 3x minus 5 divided by 3x minus 2. I'm okay with that, with one thing you have to consider. Now, 3x minus 2 is in the denominator, and that cannot equal 0, because remember, you cannot have a 0 in the denominator. So I add my 2, 3x cannot be 2, divide by 3, x cannot be 2/3. You have to add that caveat to the function. Okay, that's got to be there. It just has to be there. Okay, so that's section 2. Again, I'm glad you're watching these videos. I pray that you will. I hope that you will stick with me and continue to watch them each section. And I will see you again next time for section 3.